Welcome back, learners! Please click subscribe to learn more from our future videos. Thank you! In this video, we're going to apply the quotient rule to find the dy dx or the derivatives of the following functions. The quotient rule of differentiation states that if h of x is equal to the quotient of f of x and g of x, then its derivative h prime of x is equal to f prime of x times g of x minus f of x times g prime of x all over the square of g of x. Before we proceed to our examples, let us first recall some of the basic rules of differentiation. Let us recall that the derivative of a constant is 0. And then if we have x raised to n, we apply the power rule. The derivative will be n x raised to n minus 1. And then if we have y is equal to kx raised to n, or the constant multiple rule, we have y prime equals k times nx raised to n minus 1. If we have y is equal to the sum or difference of functions, then its derivative is just the sum or difference of the derivatives of the functions. And lastly, if we have y is a product of f of x and g of x, then its derivative y prime is equal to f prime of x times d of x plus f of x times d prime of x. And now for our first example, we can consider this numerator as our f of x, while this denominator as our g of x. So the quotient rule, we have y prime is equal to f prime of x multiplied by g of x minus f of x times g prime of x all over the square of g of x. So let us replace this with our given. So we have 7 is our f of x, right? So f prime of x means 7 prime multiplied by 5x plus 2 minus 7 multiplied by g prime of x, which is 5x plus 2 prime all over the square of 5x plus 2. Do not mistake the prime with the square. And look at the numerator also. As you can see, this is a bit similar to the product rule. It's just that instead of plus, we have a minus sign here. Okay, and then let us proceed. We have derivative of 7. So again, based on our recall earlier, the derivative of a constant is 0, right? So imagine if this is 0, then we can just remove the whole of this because 0 by anything is 0, right? And then we only have in our numerator negative 7 multiplied by the derivative of 5x is just a 5. And again, the 2, a constant derivative is a 0. So 5x plus 2 prime is just 5. And then over, so I hope you know the shortcut for squaring a binomial. We square the first term, 5x, so that will be 25x squared. And then, multiply the two terms and double it. So that will be 10x times 2, that's positive 20x. And then, squaring the last term here, we have a positive 4. And then, we have negative 35 over 25x squared plus 20x plus 4 as our final answer. Now, for our second example, we have y is equal to 3x squared minus 4, the numerator, which is our f of x, over 7x plus 2, the denominator, which is our g of x. Now, let us apply the quotient rule. So, the derivative of y with respect to x, or our y prime, don't get confused, y prime and dy over dx are just notations for derivatives. So, we have equals the derivative of f of x of the numerator. We have 3x squared minus 4 prime multiplied by the denominator, 7x plus 2. Then minus the numerator, 3x squared minus 4 multiplied by the derivative of the denominator, which is 7x plus 2. So, 7x plus 2 prime. All over the square of the denominator, 7x plus 2. There. Okay, so let us simplify this. We have 3x squared minus 4 prime. So we will get the derivative of each term here. So for 3x squared, applying the constant multiple, 2 by 3, that's 6. And then x only because 2 less 1 is just a 1, right? And as for negative 4, the derivative is a 0. So nothing more. So we only have 6x as the derivative of 3x minus 4. Then we have 7x plus 2 here, and then minus 3x squared minus 4 multiplied by the derivative of 7x plus 2, which is just a 7. And then all over, again, squaring a binomial. Square the first term, that will be 49x squared. And then multiply the terms and double it. So that will be 14x times 2, which is 28x. And square the last term, so that will be a positive 4. Then simplifying this further, of course, as you can see, we'll apply multiplication here. Then here we have to distribute the 7 and take note of the minus sign. Okay, so we have 42x squared plus 12x. And then 7 times 3 is 21x squared, and we have the negative there. So negative 21x squared. 7 times negative 4 is negative 28, and there's a minus sign there, so it will be a positive 28. And over 49x squared plus 28x plus 4. And we combine like terms in the numerator. So you can see there are terms that we can combine, like the 2x squared, which result to this 42 minus 21. That's positive 21. 21x squared, we have the x term, so plus 12x, and the plus 28. Then we have 49x squared plus 28x plus 4. And that is our final answer for this example. Now for our third example, we have y is equal to 5x cubed minus 4x minus 2 all over 3x squared plus 7x minus 1. So the derivative of y with respect to x is equal to, let's do this step by step applying the quotient rule. We have the derivative of the numerator, so that's 5x cubed minus 4x minus 2 prime multiplied by the denominator 3x squared plus 7x minus 1. Then we have minus the numerator 5x cubed minus 4x minus 2 multiplied by the derivative of the denominator, which is 3x squared plus 7x minus 1 prime all over, oh boy, this is long, the square of 3x squared plus 7x minus 1. There. So let us do the differentiation on these parts. So we have for 5x cubed, that will be 15x squared. Then for negative 4x is a minus 4. And then negative is a constant, nothing anymore. Then we have 3x squared plus 7x minus 1 minus 5x cubed minus 4x minus 2. Then the derivative of this will be 6x plus 7, right? All over the squaring of this trinomial. Let's just write this as the square of 3x squared plus 7x minus 1. What is important is we apply the quotient rule, not so much on the squaring of the trinomial. And then we have, do we simplify this further? We can distribute each term in the binomial here to each term in the trinomial here. So we have, let's do this step by step. 15x squared times 3x squared, that will be 75x raised to 4. Then this will be 7 times 15, that will be 105 plus 105x cubed, and then we have minus 15x squared. Then we have negative 12x squared. So let us write that under this same term as that. Then we have negative 28x, and then a positive 4. Then we have, for this one, that will be 30x raised to 4, and then the minus sign. So that's negative 30x raised to 4. And then we have 35x cubed. So plus 35x cubed. And then, where are we now? Here. That will be, is this correct? Negative 30x cubed, negative, we have accounted the minus sign, right? And then 5 times 7 is 35, but the minus sign before that. So that should be minus 35x cubed. And then negative 4x times 6x is negative 24, the minus sign. So plus 24x squared. And then for this one, we have negative 28, then the minus sign. That will be positive 28x. And for this one, negative 2 times 6, negative 12, then the negative. So that will be positive 12x. And lastly, negative 14, then the minus sign. That will be positive 14. Everything over, again, the square of 3x squared plus 7x minus 1 equal to, let's now combine like terms. We have 75, negative 30, so that's going to be a 45x raised to 4. Then 105, negative 35, so that is positive 17x cubed. And then negative 15, negative 12, negative 27 plus 24 is negative 3x squared. And then we can remove this. We have positive 12x plus 18. All over, again, we can just write this as the square of 3x squared plus 7x minus 1. And that's it for this example. But, oops, we have a correction here. Actually, 15 times 3 is 45, not 75. I wrote 75, sorry. So, that should be 45 only. So, it's 45, sorry, I'm using the wrong thickness. So, that will be 45. So 45 less 30 should be 15 only. So for our final answer, please check that out. Sorry. So learners, what would you like to learn next? Comment below.